One morning in a laboratory at Stanford University, a young doctor stared at his screen. In front of him was a skin cancer diagnosis produced by an AI system. The model had just analyzed millions of epidermal cell images and predicted malignant tumors with 9% accuracy, a rate surpassing even the most experienced dermatologists. But when he asked the system, "What is a cell?" it could not answer. Not because it was silent, but because it did not know. We are living in a strange era, one where intelligence no longer means understanding. A machine can predict cancer, compose poetry, and write software, yet possess no concept of the meaning behind what it creates. From a deeper perspective, this is not a story about machines becoming smarter, but about the collapse of classical logic, an age where the world no longer runs on if-then rules, but on probability. Throughout the 20th century, programming was the art of certainty. Every computer action was governed by conditional statements. If A, then B. This mindset reflected the legacy of classical logic from Aristotle to Alan Turing, where the world was seen as a chain of describable rules. But in the early 21st century, data exploded to such a scale that no one could write all those rules anymore. How do you define a cat using logical statements? A cat can be black, white, tailless, soaked in rain, or merely a blurred shadow in the night. That impossibility gave birth to machine learning, a paradigm where machines are not programmed but trained. Instead of teaching rules, we feed them millions of examples and let them discover patterns on their own. The problem is no one truly knows how they learn. Every machine learning model becomes a black box, its internal logic not written by humans but formed through optimization. If-then logic has been replaced by maybe logic. And that marks the emergence of a new form of intelligence, probabilistic intelligence. An artificial neural network does not think like a human brain, yet it mimics how the brain processes information. At the first layer, raw data images. Sound. Text flows into nodes called neurons. Each neuron has a weight and a bias, two variables that control signal strength. In essence, every layer performs a linear transformation described by the equation. Output equals F, Wx plus B, where **W** is the weight matrix. Asterisk, asterisk, X, asterisk, asterisk is the input. Asterisk, asterisk, B asterisk, asterisk is the bias. And asterisk, asterisk, F. Asterisk asterisk is a nonlinear activation function, layer by layer. The network acts like a series of mathematical filters, extracting features from coarse to refined. Early layers detect edges and angles. Middle layers recognize eyes and noses. Final layers assemble an entire face. This mechanism resembles how the human retina encodes light. Millions of photoreceptors transmit signals through layers of neurons before the brain recognizes a shape. But inside machines, everything happens through linear algebra rather than biology. The understanding here is an illusion. What we call perception is simply matrix multiplication, repeated billions of times per second. No teacher tells AI whether it is right or wrong, only error does. During training, the model generates predictions. The difference between prediction and reality is measured by a loss function. The system then adjusts its weights to reduce that error through a process called backpropagation. Imagine a sphere rolling across a 3D landscape where each point represents a different set of weights. The sphere rolls downhill along the steepest path, the gradient seeking the lowest point, where error is minimized. This is gradient descent. What is astonishing is that the entire process of AI learning is fundamentally an optimization problem. It does not understand cats or recognize faces in a human sense. It simply finds combinations of weights that produce smaller errors than others. The mechanism is both beautiful and cold. It resembles biological evolution, no purpose, no morality, only the natural selection of structures that survive more effectively. AI does not truly become intelligent. It merely minimizes mistakes, and sometimes that is precisely what makes it most dangerous. Language models like GPT do not create content. They predict the next word. Each sentence is broken into small units called tokens. For example, artificial intelligence may be split into several tokens depending on the system. When given a sequence of tokens, the model calculates the probability of every possible next token within a space of hundreds of billions of dimensions. The token with the highest probability is chosen as output. The new sequence is then fed back into the system, and the process repeats. This is conditional prediction, the foundation of all generative AI. Mathematically, it resembles rolling a die with millions of faces, each with a different probability, and learning how to throw it so the outcome appears human. As data dimensions grow, probability space becomes an abstract universe. Within it, every sentence, idea, poem, and formula is merely a point of light on an endless map of statistical possibilities. What we call creativity is often just the high-probability recombination of what already exists. When we say artificial intelligence, the word artificial makes us think of imitation, but that is no longer accurate. AI is not a copy of the human brain. It is a mathematical mirror reflecting humanity's collective knowledge, compressed into billions of probabilities. The collapse of programming logic is not the end of thought, but its transformation from rules to probabilities, from understanding to prediction. And in that world, the most important question is no longer, are machines intelligent? But rather, do we still understand what we have created?